Why, hello everyone. Welcome to Simplify and Evaluate Expressions. So we're going to get cracking on this. This is a fairly long part, so I wanted to make sure that we had enough time for it. So I'm going to jump right into it, okay? There are some various properties, and I'm going to show you guys, or at least talk about these, and then we'll move on to the problems. But when multiplying expressions with the same base, you add the exponents. 2 to the x to the fifth, 2x to the fifth times 3x to the eighth. You multiply numbers, you get 6. Then you add the exponents, you get 13. 6x to the 13. All right. If they're the same base, you add the exponents. If you are dividing the same base, you subtract them. So in this case, I know it's really hard to see. It's 6 over, like m to the 6th over 5m squared. You're doing 6 minus 2, which is 4. That's how I get m to the 4th. And finally, we have a power raised to a power. You multiply them. All right. This one and this one are oftentimes confused. I'm going to show you guys this in action real quick, okay? So let's take a look at our next page. Like I said, it's fairly long, so I want to get cracking on some of these problems. I'm going to try to zoom in just a little bit more so that we can see this better. First one, part A. I'll try and do one of each type for you guys. We can do 2 times 3 first, which we get 6. As far as x to the third times x squared goes, we keep the same base and you add the exponent. 3 and 2 gives me 5. And that is all. That's all we're trying to do here. Okay? And we're in good shape. Now, part B is a little bit different. That negative sign, let it hang out front. This fourth power goes to not only the 2, but my x cubed as well. 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. And then x to the third raised to the fourth power, we multiply these exponents. Boom, done. Can't do anything else with it. All right. So let's kind of jump over here. Take a look at this one. We'll take a look at this one, and then here we'll do C, D, and F, and we should be okay. C, this negative 2 power, I can distribute it to all of my terms. So I get negative 4 raised to negative 2 power, x to negative 1 raised to negative 2 power, m negative 2 raised to negative 2 power. Okay. Oops, sorry for the lighting here. It's terrible, I know. All right. Then, negative 4, this whole quantity raised to negative 2 power. If you have a negative exponent, you are flipping it, and then you are squaring it. Okay. So how this looks, just to show you guys over here, when you flip this, you get 1 over negative 4 squared, makes it positive, and then negative 4 squared ends up being 16. Here I can multiply. Negative 1 times negative 2 is positive 2. Stays at the top. And then over here I can multiply again. M to negative 2 times negative 2 is m to the 4th. Please note that these are both positive, therefore they stay up top. I'm really sorry for this lighting. I'm terrible at that. So then I get x to the second, m to the 4th over 16. Boom. I'm done. Alright? And we're looking good there. Okay, I just ran over and killed some of the lights. Hopefully it's a little better for you guys. Now, okay, if you guys can hang with me for these two, we should be in excellent shape. You are multiplying across. So 5 times negative 2 is negative 10. X to the 4th times x squared is x to the 6th. Y to the negative 3rd times y to the 4th. Again, remember, we're adding our exponents. Negative 3 plus 4 is just 1. Z squared times z to negative 1 is just z. 2 plus negative 1 is just 1. And we're done. So that's as simple as it gets. The final one I really want to hit with you guys is over here. And I'm going to write this a little bit bigger so you can see it, because this is just terrible. Terribly small. Okay. You are taking your top exponent minus your bottom one. So, ladies and gentlemen, what is 3 minus negative 1? 4. Minus a negative becomes positive. What is negative 3 minus negative 3 minus 2 is negative 5. So we're very, very close to being done. I don't want negative exponents though. So to combat this, I send it to the denominator. I got x to the 4th up top, I got y to the 5th down low. Boom goes dynamite. Okay? And then we're in good shape. Just trying to focus this again. I'm just off today with these videos. Maybe that looks better. I think it does. Alright. I'm going to jump. Oh, one more little thing here. Guys, what's anything raised to the 0 power? Please don't say 0. It's 1. If you don't believe me, all right, one thing you can do is take a calculator, any calculator you can find, and just put any number in there, raise it to 0 power. It will always be 1. It's a mathematical property that is quite important. All right, jumping to your back page. I'm going to do a few of these with you guys, okay? Boom, 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 and we'll be good. And then I'll take a look at the last few, and it'll be all good, okay? Square root of 125 plus root 5. You are looking to break this down with perfect squares. All right, don't go anywhere. That's me running across the room. It was lightning fast. I know. You probably blinked your eyes, and here I am. So, if you ever need to get a list of your perfect squares, there will not be a list provided for you on the keystone. So, if I hit y equals, and I type in x squared, and I hit second graph, which pulls up your table, off to the right, you have a list of all of your perfect squares. This is a tremendous asset to you. Please use it. Now, what perfect square goes into 125? 25 does. 5 times. Okay. What's the square of 25? Just 5. So I have 5 root 5 plus root 5. Treat this like you would if I asked you guys, what's 5x plus x? It's 6x. There are 6 of them now. So if I have 5 root 5 plus root 5, I now have 6 square root of 5. Good. Okay? You can only add them together if it's the same square root. If this was, say, square root of 6 over here, then you couldn't do it. It would just be 5 root 5 plus root 6. Now, please note how they're both under the square root for part B. So what you can do is put one giant square root over top of it. Can I reduce down 3 over 21? Indeedy do. I can. I get 1 over 7. Guys, what's the square root of 1? Just 1 over root 7. Now, again, we never want to leave a square root in the denominator, so this is called rationalizing the denominator. Top and bottom by root 7. I get root 7 over, what's root 7 times root 7? Square root of 49, or 7. Ta-da! All right, and then part F. All right, I'm taking a look over here. Again, I'm breaking these down. So one thing you could do, though, is you see how they're both square root of 8s? I can add what's out front first. So 5 plus 3 is 8. I get 8 square root of 8. And you might think you're well and good and done. But always check to make sure that your square root cannot be simplified down anymore. And in this case, I can break it down. It can be root 4 times root 2. What's the square root of 4? 2. So 16 root 2 done. That's supposed to be a 1 there. I know it's hard to see. Alrighty. Wonderful. The very last thing I want to leave you guys with, okay, is a little bit of square, or absolute value rather. Absolute value is considered a grouping symbol, so it's kind of your parentheses, so you do this first. Now, all absolute value does, it's the distance you are away from 0 on the number line. Distance must always be positive. Therefore, when you take the absolute value of something, it makes it positive. So in this first problem, see how the negative's shown out front? Well, the absolute value of negative 6.7 becomes 6.7, but we still have the negative there. That's why it stays as such. Here, the absolute value of negative 5.5 is just 5.5. Alright? Now, we start to get some crazier stuff here. It's not difficult. Negative 4 plus 7 is 3. The absolute value of 3 is 3. Minus 5 minus 2 is 3. The absolute value of 3 is 3. And then down low, square root of 4 is 2. Plus 4 is 6. But 0 over 6 is still 0. Yeah, that's all there is to it. Part D, absolute value is right here. Okay. Absolute value of 10 is 10. Absolute value of 6 is 6. 10 minus 6 is 4. There we go. I do want to, last thing to kind of wrap up here. If you look at part D, there is an absolute value button on your calculator. Okay, so you can actually type these entirely into your calculator. I'm typing it exactly as I see it. 5 parentheses. If you hit the math button, go to the right once, you'd see this thing saying ABS, ABS. If you hit enter here, okay, this is a newer calculator, so it actually has the absolute value bars right there. I could type in 6 plus 4, hit the right arrow key to get out of there, minus, same thing. Get out of it, close it, hit enter, and I still win with 20. This is just an option for you. You don't have to use it. I think it's helpful, but you can only do it if they're all numbers. If there's any variables in here, you could not use the calculator. So that's just a kind of little kickstart for that. Hopefully it helps. And as always, keep up the good work and good luck. We are all counting on you.